Hello guys, welcome to this new video. In this video we will be talking about merge sort, and this video is actually a continuation of our previous video where we discussed about why binary search is preferred over ternary search. And in a brief I want to just recap that binary search is actually preferred over ternary search because it has less number of comparisons than the ternary search, and also the ternary search is mm, actually having somewhat more code complexity than the binary search one. Okay, now coming to the today's topic of merge sort. So in merge sort we will be discussing that how is it implemented and what it is. So let's get to today's or this video. So in the merge sort we know that it is a sorting algorithm where we have to sort the uh, unsorted array, and it is actually a divide and conquer algorithm and not a decrease and conquer algorithm, but the algorithm is somewhat similar in implementation to the binary search, because we have to actually find the middle element and then sort recursively the sub arrays. Okay, so basically it's just the pseudo code can be written as that when we call the merge sort, we have to just first check that the right element is greater than the left index, the right index is greater than the left index or not, and if it is, then we will find the middle element as we did in the binary search as well, and we will just call the left subpart and the right subpart, and then at last we will merge with sorting the arrays, okay, to actually give back our news like the sorted array, the full sorted array. Okay, now just let's see this diagram as it is a good representation. So as you can see that um, this is a this is an unsorted array. So we will first find the middle element, which is 3, so we will divide it into two sub arrays like this one and this one, you can see, and again finding the middle element is 27, so we will divide them as two sub more arrays, and again for right sub part as well we will be doing it, and similarly, while we find 38 as the middle element, we split the sub-array into more sub-array, and at last we will be getting individual elements that are actually divided, and mm, after this call we will be calling this level, we will be actually calling our merge function. Okay, so uh, first actually, like in the code we have to actually this left half from this part will be actually called up to this level, then this right part will be called up to this level. Okay, then merging will be done here, and then merging will be done here, or okay, so with the sorting, the merging is done with the sorting. So here we compare if we will if the sorting is in ascending order, then we have to find the minimum element here, which is actually minimum in these two comparisons. So we will give the first index to this one and the second index to the larger one, and when we will merge this one as well, we will compare if this first element is equals is actually less than the first index of this one or not, and if it is, then we will give this one as the first index and 27 as the second, and and we will compare the this 43 with 38. If 38 is less than 43, then we will put 38 here and then 43. Similarly it is done here as well, and we get this array, and similar to this one we will be comparing the first two indexes, then the if let's say if there was 3 is less than 9 and we get 3 here, then we will compare if 9 was less than 27 or not. As it is less than 27, we will be getting here 9 here. Then as 9 is over, so we will compare 27 with 10, and as 10 is less than 27, we will be getting 10 here. Now we will compare 27 with 82, and as it is 27 is less than 82, so it will come here. Now we will compare 38 with 82, as 38 is less than 82, it will come here. And we will again compare 43 with 82, as it is less than 82, we will put 43 in here in the array, and at last 82 is remaining, so it will be coming here. Okay, so like this merge sort actually works. And you have to just remember this pseudo code, because this is main algorithm, and you can just see the implementation here as well. So basically here we are given the array and the size of the array, and we are just print here, it's and they have just printed actually the array to check how unsorted it is, and here they will be printing the sorted array. Okay, so in between they are actually calling the merge sort, and as discussed in the pseudocode, here we have to just check for this one, if begin is greater than equals to end or not, and it is. Here actually they have just inverted the sign, but so that they do not have to write this if statement, right is greater than L or not. They have just done that if right is less than equals to L, then just return. Okay, so this was done here. Okay, and mm, you can see that okay, wait a second. I think left one is less than right one. They have checked. Yeah, I was correct. Okay, yeah. So we will be finding middle element here, and then calling the merge sort for the left sub array, and the right for the right sub array we will be calling this function again recursively, and at last we will be merging these both uh, into a single array. Okay, so in merge sort it's just that they are finding the length of each sub arrays here, then they are creating temporary arrays and filling the temporary arrays uh, with the sub arrays that we are actually giving here, as like the index of the left index and the right index and the middle array index and the middle element index. So like this, and they are actually merging the temporary arrays here back into the arrays, and in the next one they are just copying the elements of left and then copying the elements of right in the array. Okay, so this way the merge sort actually works, and time complexity of it can be given as the recurrence relation for this one can be given as tn equals to 2 t into n by 2 plus theta of n. And if you know that the binary search also had somewhat similar kind of recurrence relation, where we had tn equals to 2 into t, sorry, not there was no 2, but t n by 2 plus 1 was there, right? So the above recurrence can be solved either with recurrence tree or master method, and as I discussed somewhat in the binary search video, this one you can check that out, that we have to actually follow this master method. So you do not worry, and we will cover some this master method somewhat more in detail, but yeah, it's just that we have to actually memorize uh, uh, an equation, and we have to memorize its conditions for the variables present there, and according to that we can give the time complexity. So as of now you can see that time complexity of merge sort is n log n, so for all the worst, average and best case, and it takes order of n auxiliary space, and this is a divide and conquer algorithm, and yeah, it's stable, and yeah, you can read this as well, but it's not that much useful. So application of merge sort is actually used for actually sorting the linked lists in order of n log n time, and in version count problem, where you have to just check how for each step in, like how much merging is remaining, like that kind of thing. Like, let's say you are giving a descending or order, you have given a descending array and you have to convert it into an ascending array, like sort into an ascending array, then the inversion count will be max in that one. And similarly, like it is, this merge sort is used in external sorting, where actually we are having a data, uh, a data that is so huge that we cannot actually fit the sorted part of it into our RAM or memory. So in that case, merge sort can be used, but see, the drawbacks of merge sort here are that it is slower compared to other sorting algorithms, and merge sort algorithm requires additional memory space order of n for a temporary array, and it goes through the whole process even the array if the array is sorted, right? So you can just see uh, what actually is happening, what I explained in the above that diagram that I showed you. And yeah, you can see other articles and coding practice for sorting and quiz on merge sort on this link. I will be providing these all in the description, and till then, for the next video,